Hey everybody, Trey here. Welcome back to another forecast discussion, giving you an update on today's severe threat for Tuesday, October 3rd, as SPC has upgraded to an enhanced risk, level 3 out of 5, for parts of western Kansas into far southern Nebraska, with an expansive slight risk extending all the way up from the South Dakota-Minnesota border downward to the Texas-Mexico border south of Fort Stockton. So a widespread area of severe weather potential today, focused on that area of western Kansas where the threat is highest with an enhanced risk. All severe hazards on the table for today, tornadoes included. We have a 5% tornado risk from southern Nebraska into western Kansas, extending all the way almost down to the Oklahoma-Kansas border, with a 2% spanning the length of that slight risk as well. Damaging wind going to be a threat today as well, especially with the northern portion of the outlook area, the northern half of the Kansas portion into Nebraska and South Dakota, where the storm mode is expected to be a little bit more clustered and linear in nature. We'll talk about that here in just a bit. And large hail, perhaps significant hail, 30% hatched area, driving the enhanced risk upgrade there across western Kansas into southern Nebraska, with a 15% hatched area all the way down the dry line into far west Texas. So lots of storms expected today with some significant severe hazards on the table. So let's go ahead and dive right in. We'll start off with our water vapor satellite imagery. And this is just some beautiful water vapor satellite imagery here as you see this big old swirl that is situated across the western half of the country. That is a very high amplitude, large, long wave trough that is making its way eastward into the central U.S. today. That is going to be our main driver for severe storms today into tonight. You can already see some activity ongoing here across the southern to central plains. Let me zoom into the current radar right now. This is the current radar. You see some showers moving across western Kansas right now and some thunderstorms moving across west into northwest Texas. Real spotty at this point, not a whole lot of widespread activity that would raise any concerns for thwarting the severe threat later, as it is expected to clear out behind this activity. This is probably some leftover activity from yesterday's threat across eastern New Mexico here. Moving into West Texas this morning, again, that is going to move off to the east and dissipate, as is this stuff here across western Kansas. You can already see it starting to fizzle out a little bit there. So we shouldn't see too much as widespread convection this morning. And that is going to allow things to destabilize behind this morning convection and really prime the atmosphere for the afternoon event. Here's our visible satellite imagery, and you can see where those storms are bubbling right now there across West Texas, and some little more bubbly updrafts there across Kansas. But again, you can see some clearing already behind these storms. I'll pause the map here as we get to our final frame. You can already see some clearing moving in behind these storms, some patchy clearing there. That should continue to make its way to the northeast and allow for some sunshine going into the afternoon. That will allow the atmosphere to destabilize and really build some instability going into storm time this afternoon. All right, let's take a look at our upper air maps here. This is the 500 millibar map here for 13Z, and you can see we've got that big old long wave trough out here across pretty much the entire western half of the country. We looked at this yesterday, a big old ridge here across the eastern half of the country, but that is starting to break down a little bit as this trough pushes its way eastward. You can see that the ridge has shrunk in size just a little bit here, at least this portion across the southern plains into the southeast. That is going to get pushed and shunted off to the east, replaced by this trough. And you can see also the kind of geometry we talked about yesterday, where we have a little bit of a shortwave developing within the main flow. You can start to see a little bit of a kink there in the height contours. That is a developing shortwave that will take on a little bit more of a negative tilt. Strong belt of flow associated with this shortwave. That will move into the southeast Colorado, southwest Kansas vicinity by early afternoon, and will be our first initiating mechanism for storms here as it moves off to the east. You'll see it a little bit better as we go through some model data as I show you the progression of this trough. But this shortwave will provide the main impetus for storms from Nebraska into Kansas, and our main impetus for storms within that enhanced risk area. Farther south, that forcing will be less and less. We will be in the right entrance region of the jet streak as it moves here. So we haven't talked about this much before. Usually we talk about the exit region of a jet streak. If you were to break it up into quadrants, the left exit region tends to be your favored quadrant for severe weather activity in these severe weather events. You can also get some in the right exit region, but in the best ascent, the best forcing for ascent, the best ingredients are often located in the left exit region of a jet streak. Well, the same is true for the right entrance region. You get the same type of dynamics, same divergence a lot, those winds spreading apart in the upper levels of the atmosphere, creating that void that the atmosphere tries to fill by bringing up air from below, and that causes the rising motion for ascent for storm initiation in a given environment. So the left exit region is the main one that we talk about, but the right entrance region is also talked about, and that right entrance region will be right over this southwest Kansas, eastern Texas Panhandle, northwest Oklahoma corridor later this afternoon, and that should allow for a few storms much more isolated in nature than farther north because the forcing is overall less. But we should see some supercells down here along the dry line here in that vicinity. We'll again show you a little bit more about that as we go through some model data in just a minute. Well, as this trough makes its way across the Rockies, we should have expected to see a pretty robust low-level response, and that's exactly what we've gotten. Very potent surface low up here across western North Dakota. Cold front draped down to the south into western Nebraska, eastern Colorado, and we will again get a dry line to develop somewhere in this vicinity here across southwest Kansas into the Oklahoma and Texas panhandles, west Texas today, as that moisture starts to surge northward or continues to surge northward and really tighten along that dry line boundary later this afternoon. So we'll again show you that a little more closely here as we go to the surface data and some of the model data here in just a bit. But overall, that surface response has continued into the overnight and morning hours from yesterday, where we didn't really have a surface response because that trough hadn't really made its way across the Rockies yet. And now we've seen that flow traverse the Rockies, and we've had a significant low-level response. And this surface low here to the north is going to traverse into southern Canada, and this cold front will continue to be draped down to the south and make some eastward progress, especially within the northern portions of the risk area across Nebraska, northern Kansas. That cold front will sag a little bit, or surge a little bit going into the late afternoon, early evening hours. And again, that is going to be a contributing factor to why the storm mode may be a little bit more messy farther to the north. Whereas farther to the south, we won't be as impacted by that cold front. We'll be having that dry line boundary as our main initiating boundary. So we will see a little bit less progressive nature to that initiating boundary, and therefore a little bit more of a window for isolated or discrete storms down with us in southern portions of the outlook area. Let's look at our 850 millibar map for our low-level jet, and you can see that low-level response has taken place very nicely. Large swath of low-level jet here, 30 to 40 knots of flow from northwest Kansas into the Great Lakes region. That should maintain today a little bit. Again, given the diurnal cycle of the low-level jet, we should see a little bit of a tailing off of that low-level jet over the next several hours, but by mid to late afternoon, we should see that ramp back up here, especially across Nebraska, Kansas, and even into far northwest Oklahoma, which is why I think the best area for if you're chasing today might be in that far southwest Kansas to northeast Texas Panhandle, eastern Oklahoma Panhandle, northwest Oklahoma vicinity. And I'll tell you why, and I'll illustrate why in just a second, but basically that's going to be your best overlap of that southern fringe of the low-level jet, along with robust instability and a more discrete storm mode down there, whereas farther north you might be a little bit closer to the core of the low-level jet, so stronger low-level flow, but the overall forcing for ascent may yield a more unfavorable storm mode for tornadoes up in that portion of the risk area. Even though we do have that 5% there for Kansas into southern Nebraska, it was mentioned in the morning outlook that the storm mode may temper the overall threat. You can see here in the last sentence here of this paragraph, tornado threat will be modulated by rather modest towgraph curvature and SRH through much of the afternoon, where the more discrete supercells are expected, and any evening increase in low-level shear will be somewhat countered by the tendency for more linear convective mode with northward extent. So SPC on the same page today with us. Stronger shear to the north, but that storm mode may be unfavorable for a notable tornado threat. Whereas farther south, more discrete modes, a little bit less low-level shear, but that overlap of the low-level shear, that southern fringe of the low-level jet, may allow for a tornado or two in the southern portions of the enhanced risk area going into the eastern panhandles and northwest Oklahoma. All right, let's look at some surface data here to really get a pinpoint on where these features are located. So, really patchy moisture, not super high moisture content. Dew point values only reaching the low 60s here across eastern New Mexico, west Texas. Your best moisture still relegated down here into far west Texas, southwest Texas. Dew points in the mid to upper 60s there. Places like Midland, Odessa. Dew point of 68 there. That should be transported northward going into the afternoon hours as we get that surface low to continue its way northeastward. Perhaps some weaker surface low development here across eastern Colorado, western Kansas that may help back and strengthen those low-level winds to pull that moisture northward a little bit more. We do have widespread 50s and 60s dew points here, though, and that is enough for a severe threat, especially this time of year, the fall season. You don't need really, those 70, 75 dew points that we often see in the spring. You can get severe weather with temperatures or dew point temperatures in the 50s and low 60s. But again, this moisture is going to be pulled northward. Probably won't see anything more than low 60s here, make its way up into Kansas, and the areas with southern extent going to be closer to that moisture source and have a little bit better quality of moisture, especially those areas of the Panhandle, northwest Oklahoma, far southwest Kansas. Anything north of that, going to be tough to get widespread, robust moisture that far north, given the track of the surface low and the overall pattern of the moisture we see here at the moment. We see that cold front. It's a little bit tough to see where that cold front is right now. Looks to be somewhere probably in here. You see a temperature and dew point gradient there. 40s dew points, 40s temperatures back here to the west. 60s temperatures out here to the east, with dew points in the 50s and low 60s. So probably the cold front somewhere in that position right now. Again, going to make some eastward progress going into the day. Some slow progress at first, and then as the trough, that shortwave kicks through, it will make its way, it will start to progress much, much faster, start to surge a little bit farther to the east and allow storms to congeal, given the strong frontal forcing there. Farther to the south, again, we'll see that dry line develop somewhere here in the Texas Panhandle to Oklahoma Panhandle, southwest Kansas. Can't really make it out right now, but we will look at some model data here in a second to see where that dry line is going to be roughly setting up this afternoon. Let's look at some soundings here. First sounding I want to look at is Midland, Odessa, where that stronger moisture was. And take a look at this profile. Look how deep this moisture is. We talked about the moist layer a lot on the channel. The red profile is our temperature profile. Green profile is our dew point profile. When those two are close together, that is basically the moist layer extending up from the surface. And we want to see that moist layer fairly deep. And usually you'll see it up in the best cases up to about 700 millibars, maybe a little bit higher or so. That's really deep moisture. Well, that moisture layer extends all the way up to almost 500 millibars here before we see this little bit of capping inversion. That is an insanely deep moist layer. We've had a lot of synoptic scale forcing for ascent over the past several hours, past day or so really, that has allowed this moist layer to deepen and deepen, and we have a very, very substantial moist layer here sitting across West Texas. We should assume that this will get pulled northward today into at least the Texas Panhandle, probably the Oklahoma Panhandle, northwest Oklahoma, maybe southwest Kansas. So again, areas with southern extent going to be experiencing much better moisture quality and moisture depth here than areas farther to the north, where we may see a little bit drier air here work its way into the low levels. But this moist layer is pretty insane here at Midland, and again, should make its way northward at least somewhat going into the afternoon hours. Let's take a look at Amarillo, Texas, and you can see we don't quite have the dew points up there yet. Dew point here at 56 at 7 a.m. Again, these are all 7 a.m. Central Daylight Time soundings. Dew point at 56. Decent moisture, though, extending up into the mid-levels of the atmosphere. Some steep lapse rate plume, indicative of an elevated mixed layer, the EML. We always talk about it here on the channel. That's that layer of warm, dry, well-mixed air that emanates from the desert southwest, western Mexico, on the higher terrain and gets pushed off and transported to the east atop that moist layer, to allow for instability to build and keep that atmosphere capped going into the afternoon, and that allows for explosive development once it finally does erode in the afternoon hours in a given severe weather event. A little bit of elevated mixed layer here, leading to some at least elevated instability at this point, and that should continue to grow. That's what is helping support these ongoing thunderstorms this morning, a little bit of elevated instability and warm air advection. You can see the looping nature of the low-level photographs. That is some low-level warm air advection going on at this point. That is allowing these storms to continue into the morning hours. But again, those should dissipate somewhat as we go into the midday, early afternoon time frame. How about Dodge City here? And we see much of the same, pretty saturated profile all the way up into the upper levels of the atmosphere, probably due to a bunch of cloud cover here. We saw that in our satellite imagery. Yet lots of cloud cover here across southwest Kansas at this point, leading to a more saturated profile. But decent moisture here, dew point at 60 up already. Some slight elevated instability, and that should only grow going into the afternoon. Photograph looks favorable here. Strong low-level warm moist advection here. Very strong veering of those low-level winds with height. Again, that will continue into the afternoon, and we should see a fairly favorable looking profile for supercells developed by early to mid-afternoon. All right, let's dive into some model data here. This is the 12Z NAM that is rolling in as we speak. And we'll start out at 500 millibars. This is how it has initialized the trough here. Pretty good initialization. Strong belt of flow on the east side of this trough. Starting to see a little bit of evidence of that shortwave embedded within the flow of the main long wave trough here, which is taking up pretty much the entire eastern half of the country. And again, this is going to make its way eastward slowly. We should see that shortwave start to develop here and move into the southeast Colorado, southwest Kansas corridor by midday or so. This is at 18Z, so 1 p.m. Central Time. And you can see the little kink there in the height contours associated with this little bit of enhanced flow there. Moving into southwest Kansas, that is our shortwave. So based on timing here, storms should form fairly early today. I would suspect by probably about 2 to 3 p.m. at the latest, given the timing of this trough and the how the moisture advection is going to take shape. So I would suspect storms fire early here across Kansas into Nebraska by about 2 to 3 p.m. or so. And then again, given the strong forcing here ahead of this shortwave across Kansas and into Nebraska, we should see a fairly quick transition to a more linearly organized complex, especially as this trough moves in. That cold front's going to start surging down to the east or east-southeast and allow those storms to encounter even more forcing. I think the window for discrete storms up here to the north is going to be very, very short, especially across northern Kansas into areas like Nebraska and in eastern South Dakota. Now, we talked about the jet streak here. So here's our little jet streak. And again, if we were to break this into quadrants and our conceptual jet streak model, our left exit region going to be up here across Kansas into southern Nebraska, but our right entrance region still hanging back here across southwest Kansas, the eastern Oklahoma panhandle, the Texas panhandle into northwest Oklahoma. So that is going to allow for a second area of storms, perhaps much more discrete, given that we still have a little bit more subtle forcing farther to the south. Here across this area, and that is the area that I'm eyeing for the most chaseable storms, if you will, for today. That far southwest Kansas, northwest Oklahoma, eastern Texas panhandle, eastern Oklahoma panhandle corridor there in the right entrance region of the jet streak. A little bit more subtle forcing along the dry line as well should allow for a longer window for discrete storms down here to the south. And that shortwave moves quickly through the flow, and we see some remnants of the overall flow. The overall long wave trough much more positively tilted. This shortwave takes on a negative tilt, but the overall trough tilted more positively. And tomorrow, Wednesday, we could see another severe threat develop across western Oklahoma into northwest Texas. They do have a slight risk out for that. We'll be back with more info as tomorrow rolls around. But focusing on today for now, let's go down to the surface and see how the surface responds. I'll keep the wide view on for now just because we have such an expansive area of surface features to look at here. So this is the 12Z initialization for the surface low located up here across western North Dakota. Cold front draped down to the south through the pressure tongue here. Somewhere in this vicinity right now, a little tough to tell, eastern Colorado, western Kansas, western Nebraska, somewhere in that vicinity right now. And again, that's going to stay put for a while as we go into mid to late afternoon. That'll start surging, though, especially the northern portions of that cold front into southern Nebraska and Kansas. So let's see how things progress here. And you see we do get somewhat weak secondary surface low development here across eastern Colorado, western Kansas. Our main surface low by 21Z, 4 p.m. Central Time, up into southern Canada, but the secondary weak surface low development here across the Kansas-Colorado border region. That should allow for some strengthening of those winds, perhaps a little bit of backing of those low-level winds as they start to feed into that surface low there across southwest Kansas. So that could be another area to pinpoint for robust storm development. And then you'll see as we go with our dew point here, dew point will allow you to see the position of the front a little bit better. Right now, dew points, patchy 60s dew points, mostly 50s dew points up across the central and northern plains, with our main moisture plume still situated well down here to the south across West Texas. But again, that should advect northward pretty rapidly going into today, especially as we get that secondary surface low to develop across the Colorado-Kansas border region. We should get a narrow ribbon of 60s dew points up into at least Nebraska, definitely into much of the western Kansas corridor, Texas Panhandle, western Oklahoma, in that vicinity as well. Again, farther to the south, closer to the better moisture, the deeper moisture, so that could bode well for severe storms down there. So let's take a few soundings here. This is at 0Z, and you'll see as we go into the early evening, that front starts to really sag. That boundary here up into the central and northern plains starts to really sag as we go into the early evening hours as the forcing moves through and pushes that boundary off to the southeast. But down here to the south, that dry line stays put very nicely and as such, we should see a more stationary initiating boundary there. Better chance for discrete storms down in the southern portion of the risk area. All right, let's take a look at some soundings here. We'll take some at 21Z, and then we'll go to 0Z. So let's take one here from northwest Kansas. We'll take one here from southwest Kansas, kind of the southwest Kansas, Oklahoma panhandle border. And then we'll take one from northwest Texas, southeast Texas panhandle. So this is farther to the north, a little bit of convective contamination here, but overall gives us a decent look at the profile. Actually, you know what? Let me pick a different sounding here. And again, the NAM is hinting at convection here, so it's going to be tough probably to find an uncontaminated sounding because it's already giving us convective feedback here at midday or mid-afternoon or so. And as I suspected, a little bit tough to get a clean sounding here, but this should do. Decent instability here, almost 2,000 joules per kilogram of mixed layer CAPE. 83/62, again, that moisture farther to the north, a little bit lower quality. So slight inverted V profiles to the north may lead to a little bit higher of cloud bases. And as we talked about before, our temperature dew point spreads, we like to keep those at about 20 degrees or less for a tornado threat. We see those a little bit on the high side by mid-afternoon. Here, but we do have robust instability, so large hail, damaging winds should be a threat. Large instability, especially in that hail growth region, minus 10 to minus 30 degrees Celsius there, so should see some large to significant hail, especially coupled with weaker low-level shear and strong deep layer shear for supercells. So we should get some supercells initially off the cold front before the forcing takes over and allows things to line out a little bit more. Okay, down here farther to the southwest, we don't see any convection here. 4 p.m. Central Daylight Time. Lots of instability here, 2,400 joules per kilogram of mixed layer CAPE. Lots of instability in that hail growth zone, so that should be favorable for large hail. Weaker low-level shear as well, and favorable deep layer shear for supercells, 50 knots of bulk shear coupled with weaker low-level shear. That is a classic look for large to significant hail here. You see some significant hail analogs taking shape here. We do have a little bit of low-level shear, though, about 120 meters squared per second squared effective SRH, and that should increase as we go into the evening. I'm going to show the 0Z soundings here in just a second, but overall, this looks like a favorable profile for all modes of severe weather, especially large hail and damaging winds. Maybe an outside chance of a tornado or two early on, but again, higher temperature dew point spreads with weaker low-level shear initially should temper that threat until late afternoon, early evening. Here we are down into Texas. Instability, as expected, more robust, closer to the moisture source there, 3,000 joules per kilogram of mixed layer CAPE. 86/68. If we can get the 68, those upper 60s dew points up into the eastern Texas panhandle, we may need to watch out there as well. Weaker low-level shear in this corridor, but strong deep layer shear for supercells. So we could see, and again, activity down here farther from the source of the forcing should be much more isolated in nature down to the south here. And just before we move on, let's go ahead and take a look at that. We'll do our shear vector technique. So our cold front here, 21Z, cold front situated like that, dry line, something like that. So farther north you go, those shear vectors much more parallel to the initiating boundary, whereas farther to the south they are much more orthogonal or perpendicular to the initiating boundary. Also a clue as to why areas farther north may see a little bit more of a tendency for a quick transition to a line, rather than areas farther south where their shear vectors are much more favorable for discrete storms. So let's go back here and we'll take a look at some 0Z soundings to see how the atmosphere progresses going into the early evening hours. So let's take, again, one up here in the far northern Kansas corridor. We'll take one down here in the northwest Oklahoma, far northwest Oklahoma, far southwest Kansas, and then we'll take one down here along the dry line in northwest Texas. So up here into southern Nebraska, northwest Kansas, right in the heart of that enhanced risk area, you can see what happens to the photographs. They start to really enlarge going into the early evening hours as that low-level jet ramps up. We start to see a very significant ramp up in the low-level jet going into the afternoon, late afternoon, early evening hours. So you see that plume of low-level jet that we talked about here at 850 millibars. It starts to get tempered a little bit going into the afternoon, but by about 0Z, between 21 and 0Z, 4 p.m. and 7 p.m., that tongue of low-level flow really starts to increase again, especially across Nebraska and Kansas, with a little bit of a tongue there sticking into northwest Oklahoma. And then by 3Z, we should see an increase in expansion of that low-level jet continue going into the early evening hours. So the low-level flow really starts to ramp up going into the early evening, and thus you'll see a response in the photographs as well. We certainly see that here across southern Nebraska, northwest Kansas. Photographs very much enlarged here, stronger veering of those low-level winds with height, Strong deep layer shear for supercells, but again, by this time, I think even though low-level shear is increasing, we will see an increasingly unfavorable storm mode for a significant tornado threat to develop up there. But those photographs definitely something to keep an eye on. Decent instability here. Those temperature dew point spreads should drop as we go into the early evening hours as the sun goes down. Temperatures start to cool at the surface and we get continued moisture advection to the north here across Kansas. Farther to the south, across southwest Kansas, northwest Oklahoma. Now, this is why I'm looking at this area as the most favorable location for severe storms, or for at least perhaps more discrete, perhaps tornadic supercells. And here's the reason. So, as we talked about before, we've already established that the best chance, longest window for discrete storms is going to be down here to the south. Far southwest Kansas, northwest Oklahoma, eastern panhandles. You still see robust instability here, 0Z, 7 p.m., 3,000 joules per kilogram of mixed layer CAPE. Those temperature dew point spreads have come down as the moisture continues to increase, and those surface temperatures come down, 81 over 66 at 7 p.m., well within that 20-degree temperature dew point spread range. But low-level shear has increased significantly here. We see effective storm relative velocity up to about 230 meters squared per second squared. Very strong veering of those low-level winds with height, veering and strengthening of those low-level winds with height, leading to much more enlarged photographs here. So any discrete supercell that can take advantage of this low-level curvature, or this strong low-level shear, strong turning in the low-level winds with height, and that the streamwise vorticity. Take a look at how the streamwise vorticity is. And again, we've talked about this before. Streamwise vorticity is just your storm relative wind vector, drawn from the storm motion to the hodograph point of interest, and then your shear vector, which is to the left and perpendicular to the hodograph. And when those two vectors are parallel, that is a purely streamwise environment. You can see here in the low levels that is the case. Very much strong streamwise vorticity here in the low levels. That is going to aid in any tornado threat come early evening hours. One thing to note here, a little bit of backing in this mid-level hodograph here. We've talked about veer back, veer before, this kind of S shape or M shape in the hodograph. Whether or not it's going to be an issue in the duration, longevity, intensity of mesocyclones, still in question. I always tend to think that the lower this veering is, if it's within the effective inflow layer, you tend to have a little bit more of an impact from that veer back veer. But I think the more important things that are going to influence tornadic activity and supercell longevity, mesocyclone longevity and intensity is going to be the streamwise vorticity, strong low-level shear, strong veering of those low-level winds with height. That is going to play more with the pressure perturbations in the storm and really drive the mesocyclone characteristics with these storms instead of this little bit of backing here. A little bit of backing due to a little bit of this area is a little bit farther removed from the stronger 700 millibar flow, which is off to the northeast. So that is why we're seeing a little bit of a kink here in the hodographs. But we do have strong low-level streamwise vorticity and strong veering and strengthening of those low-level winds with height. So shouldn't be too much of an issue today given a discrete supercell mode established, as we've already established. Down to the south, stronger instability, weaker low-level shear into northwest Texas down along the dryline. That should foster mostly a long-duration, large hail threat, given very robust instability in that hail growth zone and weaker low-level shear, strong deep layer shear for supercell. So any development that happens farther south along the dryline into northwest and west Texas should favor a more large hail and damaging wind threat than a tornado threat here. So the sweet spot to me looks to be right in that corridor of far southwest Kansas, eastern and northeastern panhandles into northwest Oklahoma. That should be our favored location for discrete supercells with a large hail, damaging wind, and perhaps a tornado threat going into the early evening hours as that tongue of low-level jet makes its way down to the south a little bit. The very southern fringes of the low-level jet makes its way down to the south. All right, let's take a look at some convective allowing model data. This is the 12Z HER we'll start off with, initializing some of those storms across West Texas into the western half of Kansas, dissipates those as we go into the late morning, early afternoon hours, and then by about, again, 19 to 20Z, 2 to 3 p.m., we start to see robust storm initiation here, all the way from the Kansas-Oklahoma border up into Nebraska here. And you can already see very quickly we get a very clustered, messy mode right from the get-go, and that is due to the very strong forcing from both the shortwave and the cold front, going to allow a lot of updrafts to go in close proximity to one another and a very clustered linear mode. We do see some elements in here of maybe semi-discrete supercells, especially down here on the southern end, perhaps a little bit of a tail end Charlie there across southern Kansas. Could be something to watch for sure. As we go into the early evening hours, that really starts to dissipate. We really get a taking over of the line/clustered mode. And then we get some additional development here down to the south. Her not showing much in the way of development here across the southwest Kansas into the Panhandles, northwest Oklahoma corridor. Some activity down here along the dry line, but something to watch for sure. And again, this is just one model, and we're taking these with a grain of salt because they just don't do a great job of depicting the overall environment in these types of events. But at least gives us a decent estimate of what the radar might look like, and the at least best chances for storms to go are going to be up into the northern half of Kansas into Nebraska for sure, quickly transitioning to a linear mode. This is the WRF ARW here. Doesn't have a lot of that convection early on across Texas and Kansas, so that is something to keep in mind with this particular model run. Nonetheless, not much activity going on by early afternoon, and then by about 1920Z or so, we start to see development here across western Kansas into Nebraska. Some semi-discrete elements in here, especially farther south. We see more semi-discrete supercells in there, whereas farther to the north, much more of a clustered linear mode, as expected. And then things eventually will congeal into a line going into the early evening hours. NSSL WRF, just another cam that we'll take a look at here, has so this is a little bit different here. It has quite a bit of activity blossoming here going into even early afternoon across at least the southern portions of the risk area into the Panhandles, southwest Kansas. That'll be something to watch. It does eventually look like it turns into some robust convection here, moving across southern Kansas, western Oklahoma, with just a line of storms behind that. So very interesting here. We'll have to watch if this comes to fruition, if we get more development out here early on that may temper the overall environment. We'll just have to wait and see with that. But most of the models do not have that convection blossoming until that shortwave makes its way through into the southwest Kansas area. Final one we'll look at here is the FV3. It doesn't have a ton of that early activity, and then lots of storms going up by 19 to 20Z, 2 to 3 p.m. We do see some more isolated storms here, even up into northern Kansas, interestingly enough, on the FV3, with some isolated supercells down there in southwest Kansas as well, before congealing into mostly a line, with some additional activity here across the eastern Texas Panhandle, western Oklahoma. We'll have to watch that area for sure to see if anything fires farther to the south. Again, would have mostly a large hail threat being farther removed from the stronger low-level flow, but nonetheless needs to be watched for sure. So interesting breadth of solutions among the models here. It's definitely not an easy setup to pinpoint, but I do think that sweet spot is going to be somewhere there. Southwest Kansas, far northeast Texas Panhandle, and the eastern Oklahoma Panhandle, northwest Oklahoma this evening. So once again, enhanced risk out for western Kansas and far southern Nebraska, with a large slight risk area extending all the way up through Nebraska and eastern South Dakota, southwest Minnesota, and all the way down to the Texas-Mexico border south of Fort Stockton. Once again, all hazards in play. Tornado threat, 5% there within the enhanced risk area from southwest Kansas into southwest Nebraska. Damaging wind and significant hail going to be a threat, especially within that enhanced risk corridor in western Kansas. All in all, a very interesting setup for the fall season. Again, I think with northward extent probably from, about Garden City, Scott City, Kansas, northward, going to be a tendency for storms to really rapidly cluster or line out this afternoon. We will see at least a small window for discrete supercells with a significant hail damaging wind threat up there to the north. And by the time low-level shear gets stronger going into the late afternoon, early evening hours, storm mode should be very unfavorable for tornadic supercells up there. Farther to the south, the southern portions of the enhanced risk going into the slight risk area across northeast Texas Panhandle, northwest Oklahoma, I think is going to be the sweet spot for discrete supercells with a large hail, damaging wind threat, and perhaps a tornado threat as that southern fringe of the low-level jet makes its way southward into that region by late afternoon, early evening. So we'll have to watch that for sure. That will be my chase target for today. Farther to the south, much less low-level shear, mostly a large hail threat with any storms that can fire along the dry line farther to the south and southwest. So a very widespread area of severe storms focused on that corridor in western Kansas where the enhanced risk is located. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.